the Artemis 1 countdown just past T-minus 2 hours, 40 minutes, heading down toward the next hold, pre-planned hold at T-minus 10 minutes. With the core stage liquid hydrogen tank now topped off and in replenish mode, the launch team is given the go to start the core stage engine bleed kickstart. This is a procedure that will flow small amounts of liquid hydrogen into the engine compartment of the Space Launch System core stage to begin the process of thermally conditioning those engines for flight. This engine bleed kickstart procedure is associated with a quick disconnect that was found to be leaky during a wet dress rehearsal or practice countdown back on June the 20th. The launch team was able to proceed with that practice countdown despite this leak. They developed some procedures to mask the leak essentially from the computer system, the countdown sequencer, to allow the terminal countdown to proceed down to roughly T-minus 30 seconds during that practice countdown run. But that leak in the quick disconnect associated with the engine bleed for the Space Launch System core stage would have been a constraint to launch if that June 20th countdown had been a real countdown and not a rehearsal. NASA's ground processing team here at the Kennedy Space Center believes they successfully repaired that leak once the Space Launch System was returned to the vehicle assembly building. That repair was performed at ambient temperatures, and leak checks were performed on that quick disconnect at ambient temperatures using helium. But hydrogen is a smaller molecule. It's also at cryogenic temperatures, more than 400 degrees below zero. So the size and shape of this quick disconnect changes as it's subjected and exposed to cryogenic temperatures, and it makes it difficult for teams to say with certainty that they've fixed the leak until the same hardware is again put under cryogenic conditions. So we're about to see that in the next few minutes as this engine bleed kickstart procedure gets underway, and the launch team will get their first look at whether that repair is holding and whether the leak in that area has been resolved. This is a separate leak from the potential leak that we were talking about earlier in the countdown. It's in the same general vicinity near the tail service mast at the bottom of the core stage, but it's a different line. NASA's Artemis 1 countdown just passed T-minus 2 hours and 10 minutes, now 2 hours, 9 minutes, 41 seconds and counting. The countdown is heading toward a built-in hold at T-minus 10 minutes. That's about 2 hours away from this point. That built-in hold is was expected to last about 30 minutes, but it's likely to be extended. The latest report from Jeremy Graber, the assistant launch director for Artemis 1, is that the team will reassess the timetable for when the Space Launch System might be ready for launch this morning. During that 10-minute hold at T-minus 10 minutes, there are 2 hours available for this morning's launch window, opening at 8:33 a.m. Eastern Time, or 12:33 UTC, closing at 10:33 a.m. Eastern, 14:33 UTC. The weather forecast continues to show an 80% chance of favorable weather at the opening of the window this morning. That probability of go or acceptable weather decreases to about 60% at the end of the 2-hour window due to the increasing threat of scattered showers as we get later into the morning here at the Kennedy Space Center. Right now, all weather parameters are observed green for launch. We had the chance to talk with Stu McClung, an engineer on the Orion team. He has worked on the Orion spacecraft for a great number of years, dating back to the early phases of that program's development. He's based at the Johnson Space Center in Houston. And here are his thoughts on the Orion spacecraft and the test flight it will be carrying out on Artemis 1.
Okay, I'm with Stu McClung, an engineer on the Orion program for NASA. Thanks for joining us, Stu.
Thanks for having me.
So this is a big test for the Orion spacecraft that's going to be taking it around the moon. But Orion has flown in space before, back on the exploration flight test. What is new on this particular mission, Artemis 1, that you were unable to test on EFT-1?
One of the most obvious things that folks will see, of course, this will happen on entry and landing day. And one of our key test objectives will be to demonstrate the heat shield performance at lunar reentry velocity. Right? So again, we had a heat shield on EFT-1. We got a good test of it. It was a slightly different config. It was what we call a monolithic heat shield. This one, as you should be familiar, has 186 blocks, same material, but the block layout and now we get to take that layout combined with the reentry velocity and validate that all of our ground-based testing that we've done in arc jets and other tests along the way is accurate, and we've got the proper margins built into it. And so that's one of the more obvious differences between EFT-1 and Artemis 1. And like you mentioned, we're off to the moon and lunar vicinity and out and beyond. And so with an extended duration, we'll have the opportunity to test my solar arrays and put them to really see how they perform. And as we do sun tracking, every system we have the opportunity. We have well over 100 test objectives that we'll work through as the mission goes along, and to validate system performance as we go along the way. Inside the cabin, we've got some mannequins. It's uncrewed mission, but I've got 2 mannequins that are set up in seats 3 and 4 that will be measuring the radiation environment that you see once you get outside the Van Allen radiation belts out in the lunar vicinity. Identical mannequins, but one's got a mask, or not a mask, one has a vest on it. They're both instrumented, and so we'll see how does that vest, what level of protection does it provide the future crews to, and we'll feed that into future designs. We got a third, the Campos, or the moon, or the one that's sitting in the commander's seat, will be instrumented to measure ascent vibration, entry vibration, landing acceleration type loads.
And you mentioned the solar arrays. So the service module was a new thing for Orion for this mission entirely, right?
Well, that's a great point, right? Yeah, this really is the first full test of the service module. We partnered with the Europeans, basically leveraged the partnership that exists today on space station, and we've had really great success partnering up with our international partners. They came to us, joined us, all right? So part of the service module is built by Lockheed, the external structure, the power plant, the solar arrays, are provided by EASE and Airbus. That gets assembled in Bremen, shipped over here. So yeah, this will be something we couldn't do on EFT-1, where we'll test the entire propulsion system, the in-space propulsion system and power system for an extended mission.
I know after Artemis 1 comes back, there may be some lessons learned that you have to apply to the Artemis 2 vehicle that's being prepared right now here at Kennedy.
Right.
All things being equal, though, what are some of the planned differences and changes between the Artemis 1 configuration and the Artemis 2 configuration when you have crew?
So if we learn something significant enough that we need to modify it from Artemis 1, right, we would have that discussion and on-ramp that into Artemis 2 if it needs to be done, right? That would depend on what you might learn. Outside of that, we're bringing on the rest of the systems that are required for the crew, the rest of the ECLSS systems that are being tested in labs today, anything else. So the most obvious thing would be just the rest of the crew support systems. And on Artemis 2, we will fly a rendezvous, a portion of a rendezvous to demonstrate our rendezvous capability ahead of when we rendezvous at the moon on Artemis 3.
In terms of the in-cabin atmosphere for this mission, you have the mannequins you mentioned. Would an astronaut be able to survive in that cabin on this particular mission, or are there still ECLSS functions missing?
There's ECLSS functions missing. We've got it pressurized. We'll maintain cabin pressure, but we're not maintaining cabin pressure with a standard breathable atmosphere. So we've got the proper pressure. We just don't have we don't have the need for the right mix. But yeah, so nobody on board this time around, and the mannequins won't complain about it.
If you could maybe point out some of the features on this model, like the different components, and what do you think is important to note?
All right, well, so Orion, and I always point this out to folks, right? Orion is the white section on top, right? So SLS is below me, right? So my SLS friends would call me a payload. In the launch abort system that you see here is not here in this model. Launch abort system sits on top of the vehicle. Then the crew module, service module below. The crew module is, I was going to pop it out, right? When we re-enter, the crew module is the only thing that comes back. The service module travels with the crew module for the entire duration of the mission until about 20-30 minutes before entering the Earth's atmosphere. Then we jettison it, separate, and it separates and then burns up in the atmosphere. Docking system is shown on top. On Artemis 1, there's no docking mission, but this model shows a docking mechanism that we'll have in future missions. See the umbilical here? This, again, the commodities, the power are carried down here in the service module, and there are a series of, if I remember right, about a dozen lines, combination of fluid and electrical lines that come up through this umbilical and then connect into the side of the crew module. And so, again, as we separate the crew module and service module, this is commanded to separate. There's some pyrotechnic bolts in there that push it away, and it hinges out of the way. You see the RCS thrusters around the side. When we're landing, when you open up and you're under 3 big main parachutes, and each main parachute's 116 feet in diameter. So at the end of the mission, when we're under our 3 mains, we are going to go where the wind takes us, clearly, right? You're going to go where the wind carries you. And but one of the things we do and one of the things we'll test is we steer the vehicle using these thrusters so that when the astronauts land, their legs, if you think about laying into a seat, they're going into the velocity vector because the seats are designed to attenuate that landing load. And so we're giving them a straight-on entry versus a side hit. And so the thrusters, the propulsion system on the crew modules is important come landing day. To make sure that we give the crew a controlled re-entry and splashdown.
What's the expected splashdown velocity?
Splashdown velocity under 3 chutes is 25 feet per second, which is about 18 miles per hour. The rest of the vehicle designs assuming that we lost a main parachute. As you understand, right? We design to always survive those first failures, put fault tolerance and redundancy into the vehicle. So if we're under 2 mains, it's 33 feet per second instead of 25. But the structure and everything else is designed assuming that happens. And so when we give them 3 good mains, right, they're well within guidance.
And I think you pointed out the launch abort system. This particular mission does not have a launch abort motor, if I understand correctly.
That's correct.
Obviously, you don't have crew on board, but why not have the full configuration?
It was a trade, since we had done pad abort 1 test of the launch abort system, and then the ascent abort test that we did here at the Cape 3 years ago. Don't need to test it, and so basically it was a cost savings trade. So we're not going to abort. It does have the jettison motor, so once we get up in the right stage of ascent, it will jettison and fly away. So we just made that trade. The Artemis 2 one clearly will be fully outfitted, but we were able to test the launch abort system independently to the point that we don't need to rely on Artemis 1 as a test event for the abort motor.
Okay, Stu, thanks for joining us. Good luck with the mission.
Thank you. Looking forward to it.
That was Stu McClung, an engineer on the Orion program, working on the Orion spacecraft. He's based at the Johnson Space Center in Houston, and here's a look at the Orion spacecraft mounted on top of the Space Launch System out on Launch Complex 39B this morning. The core stage remains fully loaded with propellants at this time. Liquid hydrogen loading on the second stage is underway. We've got an update from NASA on the status of that engine bleed kickstart procedure that I talked about a few minutes ago. This is the procedure that flows small amounts of liquid hydrogen from the core stage into the engine compartment to begin conditioning the 4 RS-25 engines at the bottom of the core stage. NASA reports that the engine bleed for 3 of the 4 engines appears to be working normally, but they're not seeing the bleed they want to see for engine number 3 on the core stage. So the launch team is currently troubleshooting that issue. One of the next steps in this bleed configuration is to set up for what they call a pre-press test. This is when the launch team will close vent valves on the core stage, build up some pressure in the tanks, and then that will help the team confirm that there's no leak path in any of that bleed system. There was a leak discovered in one of the quick disconnects in the engine bleed line back in June on a countdown rehearsal. NASA technicians believe they repaired that quick disconnect leak in the vehicle assembly building when the Space Launch System was rolled back to the hangar following that June 20th countdown rehearsal. And then, of course, the rocket was returned to pad 39B a couple of weeks ago in preparation for this morning's launch attempt. The countdown clock here at NASA's Kennedy Space Center just passed T-minus 1 minute, or 1 hour, 56 minutes. Heading down toward that next built-in hold at T-minus 10 minutes. And we expect to hear, assuming the countdown proceeds down to that point, we expect NASA's launch team to set a new target launch time sometime during that 10-minute hold. And then we'll learn when NASA hopes to target the launch of the Space Launch System this morning, the first flight of this Artemis 1 moon rocket. In this view, you can see the vehicle out on pad 39B, lit up by spotlights this morning. To the right, you can see the flame stack at Launch Complex 39B. This stack burns off any excess hydrogen gas that may be in the, or hydrogen rather, that may be building up in the atmosphere. It helps to burn off any hydrogen that could cause a flammability or explosion risk out at the pad. And that flame stack becomes more active once hydrogen begins loading into the launch vehicle. NASA reports that the launch team is now assessing what appears to possibly be a crack in the intertank flange area on the core stage. There is some frost building up in that apparent crack, and engineers are now discussing whether that might be a concern for the remainder of the countdown and the launch this morning. Not yet clear how serious this issue might be. And another update from Artemis Launch Control. NASA says the liquid hydrogen team is continuing to try to get a good bleed flow to engine number 3 at the bottom of the core stage of the Artemis 1 moon rocket. After adding some pressure to the core stage tanks, the team still wasn't able to get the bleed flow they wanted leading into engine number 3. The other 3 engines have a good bleed to begin their thermal conditioning process before ignition. So right now the team is discussing or planning to pressurize the core stage up to flight level to try to add even more pressure into that system to try to force through that bleed flow of liquid hydrogen to begin thermally conditioning engine number 3. Again, the other 3 engines do have a good bleed flow according to NASA. You can see here this zoomed in view without zooming out, some great detail on the Space Launch System core stage, looking in the general vicinity of the engine section. There's one of the attachment struts connecting the Solarika booster, one of the Solarika boosters to the core stage. The launch team is continuing their video survey using these remotely operated engineering cameras mounted on the mobile launch platform and the mobile launcher tower at Launch Complex 39B. T-minus 1 hour, 33 minutes, 19 seconds, and counting. There are still a couple of issues that are being worked by the Artemis 1 launch team right now. One of them involves the engine, the bleed flow to engine number 3 on the core stage. This is a hydrogen bleed that is necessary to thermally condition the 4 RS-25 engines for engine start, which occurs at about T-minus 6 seconds in the countdown. 3 of the 4 engines have a good bleed flow according to NASA's Artemis Launch Control Team, but engine number 3 still is not within the correct parameters, the right temperature that they're looking for getting within the parameter space, proper conditions for engine start. So the team believes there's not enough pressure in that bleed flow leading to engine number 3, and there are several different troubleshooting actions that the team has conducted or is conducting to try to get that pressure up to restore that bleed flow to sufficient levels to get that engine within the proper thermal bounds for ignition. Now 2 hours remaining until the start of today's Artemis 1 launch window, which itself runs 2 hours. So actually it's 2 hours away from the opening of the window now, 4 hours away from the closing of today's Artemis 1 launch window. Here's a gorgeous view from the Kennedy Space Center press site this morning. You can see the crowds of news media gathered here, roughly less than 4 miles away from Pad 39B, where the Space Launch System moon rocket is awaiting a possible launch opportunity this morning to carry NASA's Orion spacecraft out to the moon on a 42-day test flight. This is the first launch of NASA's Artemis program, the first flight of the Space Launch System, which, when it takes off, will become the most powerful rocket to ever have launched from U.S. soil. A beautiful dawn here on Florida's Space Coast. You see the countdown clock on the right, T-minus 1 hour, 24 minutes, 30 seconds. The countdown is heading toward a built-in hold at T-minus 10 minutes. And at that time, we expect that hold to be extended beyond the planned 30-minute duration to target a launch time sometime within the 2-hour window this morning, which opens at 8:33 a.m. Eastern or 12:33 UTC. We don't expect the launch to occur at the opening of the window. We expect NASA to target sometime later in the window, and that assumes that these open, unresolved issues, such as the potential crack or at least a line of frost or ice buildup on the intertank area of the core stage that NASA is studying, as well as the bleed flow to engine number 3. Those issues still need to be addressed before this mission can get off the ground this morning. We're watching gorgeous views here from the Kennedy Space Center as the sun light begins to creep above the eastern horizon out over the Atlantic Ocean. The flame stack to the right of Pad 39B flaring up, burning off hydrogen. You can see the crowds gathered here on the lawn of the Kennedy Space Center press site. The latest report on the status of that engine bleed issue on engine number 3 of the core stage is that the launch team has cycled a bleed valve associated with that multiple times at least. and that has not yet resolved that concern, that issue with the bleed flow into engine number 3. Really is a gorgeous morning here at the Kennedy Space Center. If you're just joining us, we've been covering the Artemis 1 countdown throughout the night. It's been a bit of a roller coaster journey with stops and starts of a liquid hydrogen flow on the core stage after the detection of an apparent leak in the tail service mast umbilical. That's the connection between the mobile launch platform and the core stage through which propellants flow into the rocket. But after some troubleshooting, the launch team got that leak down to safe, manageable levels and within limits. That allowed the team to proceed through loading the entire tank of liquid hydrogen. 537,000 gallons were loaded into the core stage. In parallel with that activity, liquid oxygen also flowed into the core stage. So the core stage right now is full of 733,000 gallons of cryogenic propellants. Loading of propellants into the upper stage has also gotten underway. We haven't heard any exact status report of where exactly that stands right now in some period of time, but we're not aware of any issues with loading the upper stage of the Space Launch System moon rocket. So after clearing the hurdle with the potential hydrogen leak in the tail service mast umbilical area on the launch platform, we did hear reports from the Artemis launch team that the bleed flow into engine number 3, this is a flow of liquid hydrogen to thermally condition the engines for ignition. That bleed flow was not satisfactory, was not meeting expectations. The other 3 engines do have a good engine bleed kickstart to begin that thermal conditioning process. And so far, the troubleshooting efforts to try to recover that bleed flow into engine 3 have not been successful. But NASA engineers are continuing to evaluate their options on how they might be able to recover that. and still proceed with the launch this morning. Early on in the countdown, overnight or late last night, the loading of cryogenic propellants also got a late start due to some stormy weather that was approaching the Kennedy Space Center area with the threat of lightning. So the propellant loading started nearly an hour behind schedule, and then fell further behind with that troubleshooting of that liquid hydrogen leak in the tail service mast umbilical area. And now the team is working another issue with the engine bleed to engine number 3 on the core stage. There's also been discussion of a line of ice or frost that may be indicative of a possible crack in the thermal protection system or foam insulation on a portion of the core stage. We're not really sure how serious that issue might be, if that's a real issue or whether that's just something the team is trying to look at to make sure it's not an issue or not a concern for the countdown this morning. So we'll wait on the word from Artemis Launch Control on those discussions. NASA has said that there's a lot of expectation among the launch team members that the launch time, assuming these issues are cleared, will have to be delayed into the launch window this morning. So it's unlikely that the launch will happen at 8:33 a.m. Eastern Time. There is a 2-hour window to get this Artemis 1 lunar test flight off the pad here at the Kennedy Space Center. That window closes today at 10:33 a.m. Eastern Time, or 14:33 UTC. Later on in the window this morning, there is an increasing threat of rain showers that could violate the flight through precipitation rule. The launch pad and the flight path of the Orion spacecraft and the Space Launch System have to be clear of any precipitation to allow this launch to proceed. Going into this countdown, the weather team expected the conditions at the opening of the window to be better than at the end of the window. NASA does have backup opportunities available to launch this mission if the launch can't get off the ground this morning. The next opportunity would be Friday, no earlier than Friday, September the 2nd. Now, T-minus 1 hour, 10 minutes, and counting. We're about an hour away from the built-in hold at T-minus 10 minutes. That's when the countdown clock will be stopped. This is a pre-planned hold in the Artemis 1 countdown. The latest update from NASA's Artemis Launch Control Center here at the Kennedy Space Center is that the launch director, Charlie Blackwell Thompson, has approved a new troubleshooting step to try to recover this engine bleed to engine number 3 to get that engine down to the proper thermal conditions, proper temperature for flight. The engine bleeds to engines 1, 2, and 4 has been those bleed flows of liquid hydrogen into those engines have been working, and the next plan will be to close valves leading into those engines to eliminate those bleeds and to force the bleed pressure from the tanks or the tank of the core stage down into engine 3 to try to ramp up that pressure to get liquid hydrogen flowing down into that engine to get it to the proper temperature and to go condition for flight today. This is a cool view from Launch Complex 39B, looking at one of the umbilical arms. This is one of the arms that will swing away from the rocket at launch time. One of the nose cones to one of the solid rocket boosters is also visible. That black band just under the nose cone. One of the boosters has that black band to distinguish it from the other booster. In the background to the right is the vehicle assembly building, some 4 miles away. This view of the Space Launch System on pad 39B comes from a camera on the roof of the Vehicle Assembly Building. We saw the VAB a few moments ago from the vantage point of pad 39B. Now you're seeing pad 39B from the VAB. In the background, there's a security vessel, likely a Coast Guard vessel, just offshore in the Atlantic Ocean. These vessels are periodically visible just off the coast during launch countdowns to clear the maritime exclusion zones, make sure there's no ships or any other traffic in the area under the flight path of the rocket. T-minus 1 hour, 3 minutes, 30 seconds, and counting. This view from a camera on board one of the lightning towers out at pad 39B shows a great shot of the Atlantic coastline. I want to draw your attention to the right of the frame. You can see SpaceX's Launch Complex 39A there in the background. The rising Starship launch tower visible there at pad 39A, as well as the fixed service structure that supports crew launches on the Falcon 9 rocket that SpaceX uses to send astronauts to the International Space Station. Farther in the background, you can see United Launch Alliance's Launch Complex 41 area for the Atlas V rocket, also home to a crew access tower for future crew flights on the Atlas V and Boeing's Starliner spacecraft. So here in this one frame, you can see the 3 human-rated launch pads at the Kennedy Space Center and at Cape Canaveral Space Force Station. In the foreground, obviously, the Space Launch System for the Artemis program to carry astronauts back to the moon. Beyond that, pad 39A for astronaut flights to the space station. And in the distance, pad 41, ULA's Atlas V launch complex that is ready from a ground systems perspective to support crew launches on the Starliner spacecraft built by Boeing. In the lower, well, here's a view of pad 39A from the press site here from a camera we have looking out toward the east toward launch pad 39A. You can see that Starship tower. 7 of 9 segments have been raised and lifted onto that tower. Also, the water tower that's going to be used to support Starship launches from pad 39A is also taking shape. And on the left is the Falcon 9 launch mount and the transporter erector arm for Falcon 9 rockets sitting horizontal down on the top of the pad, ready to roll back into the hangar sometime in the coming days to pick up another Falcon 9 rocket for the next flight from this pad. On the lower left of this view, you can see one of the transfer lines, one of the cryogenic propellant transfer lines, those vapors venting away from that cross-country line leading to one of the cryogenic storage spheres out at pad 39B. So earlier in the countdown when we were talking about chilling down the transfer lines, that's one of those lines that flows propellants from the ground storage facility into the rocket. Just past the T-minus 59-minute point in the Artemis 1 countdown. No further update in the last couple of minutes on the technical issues being worked, namely the bleed flow to engine number 3 on the core stage, and this line of frost or ice and a potential crack in the intertank area of the core stage. We haven't heard anything about that issue in some time, actually. Most of the chatter from the NASA launch commentator of late has been focused on this engine bleed issue. Typically at this point in the countdown, we'd be hearing chatter from the launch control team members themselves as they work through issues like this. But NASA is not releasing any of the countdown audio nets until the point about 15 minutes before liftoff. At that point, we will get some audio feeds from the Launch Control Center. We can listen into the launch director poll at that point. But we're not hearing any of the discussions on the countdown loops as the team works through these issues and has worked through the tanking of the Space Launch System moon rocket. NASA has cited export control restrictions for not releasing this audio to the media and to the public. So if you're wondering why you're not hearing audio from launch control, from the launch director and the other members of the launch team, that's the reason, according to NASA, is they're not releasing any of that audio until the launch minus 15-minute point. 15 minutes before launch is when we'll begin hearing that audio. Other companies, other launch providers such as United Launch Alliance and SpaceX do release some countdown audio during the fueling process of their rockets to the news media to allow for coverage of their launches, but not the case for the Space Launch System, at least for this first test flight on Artemis 1. We're not going to hear that until the final 15 minutes of the countdown. We're also not seeing any video of the launch team inside the firing room as they work through these issues. In the past, it's been customary for NASA launches dating back to the shuttle program to have camera views inside the firing room to show the launch team members in a wide view as they work through the countdown, but we're not seeing that this morning either. Just a minute or so ago, we did hear another update from the NASA launch commentator that the launch director has asked the team to come up with next steps to determine what to do next in this countdown. Again, there's the open, unresolved issue involving the bleed flow to engine number 3 on the core stage. That engine has not been able to get down to the proper operating temperature for engine ignition and launch. The flows to the other 3 engines have been working properly according to NASA. And there was discussion a little bit earlier this morning about possible crack in the intertank area of the core stage. We haven't heard much about that in the last few minutes, but we'll stand by for news there. Also, there's the lingering issue that was an issue from the very start of the countdown, or the very start of cryogenic tanking operations, which involves a communications issue with the Orion spacecraft. We haven't heard anything about that in some time, as events may have overtaken that with all these discussions about leaks and the bleed flow on engine number 3. So we'll stand by for word from NASA on whether that Orion communications concern has been fixed or resolved. good view of the RS-25 engines, 4 of those engines mounted on the bottom of the core stage. And the liquid hydrogen bleed flow into one of those engines is the main concern under discussion by the Artemis launch team right now. The liquid hydrogen team in the Launch Control Center is continuing to discuss options to continue troubleshooting this bleed flow into engine 3 that's not providing the engine with the proper thermal conditions for flight today. This bleed involves flowing a little bit of liquid hydrogen into the engine plumbing to get those engines chilled in for engine start. They need to be within the proper temperature bounds. There's a lower and upper limit for that. And engine number 3 is not currently able to reach within those temperature bounds due to an issue with this bleed flow. Here's a view of the Space Launch System out at Pad 39B. We've passed sunrise here on the Florida Space Coast. On the lower right, you can notice some vapors around the transfer line for liquid hydrogen that flows up the incline to the top of the launch mount from a storage sphere on the northeastern perimeter of Pad 39B. The liquid hydrogen tank for the core stage is currently in replenish mode. So there continues to be a little bit of liquid hydrogen flowing through that transfer line into the core stage to gradually replace the liquid hydrogen that pulls off into a gas to make sure that the core stage tank remains at flight level. Same thing going on with liquid oxygen. The liquid oxygen tank is in the distance. You actually can see that liquid oxygen sphere in the distance on the lower right of this screen on the northwestern side of the pad. Here's a view from one of the engineering cameras at Pad 39B showing the 4 RS-25 engines on the bottom of the core stage. Engine number 3 is the one that's experiencing this problem with the bleed flow of liquid hydrogen. And just getting our geometry right, we believe that the engine number 3 is on the lower left in the foreground here. The engine that's most prominent in this field of view, we believe, is engine number 3. Each of these engines can produce about 500,000 pounds of thrust in the vacuum of space, roughly 400,000 pounds at sea level, and they consume liquid hydrogen fuel and liquid oxygen as oxidizer. NASA says that there will be an unplanned hold inserted into the countdown at T-minus 40 minutes to allow the liquid hydrogen team to continue their troubleshooting. We expect to see the clock here stop momentarily. T-minus 40 minutes and holding. The countdown clock has stopped at 40 minutes. This is an unplanned hold in the Artemis 1 countdown. This is not yet an indication or confirmation that NASA has scrubbed or thrown in the towel for this morning's launch opportunity, this morning's launch attempt. There is still some troubleshooting plans being developed by the launch team to try to restore this bleed flow to engine number 3 to get that engine down to the proper operating temperature for launch. The liquid hydrogen team will take a few minutes here to develop that plan and present that plan to the launch director, Charlie Blackwell Thompson, and then she will consider that and decide whether to implement those troubleshooting steps. The countdown had been ticking down toward a planned built-in hold at T-minus 10 minutes. There still will be a hold at T-minus 10 minutes if this countdown clock is able to resume. There still will need to be a hold at 10 minutes to allow for the polling of the launch team for a go or no-go to enter into the terminal countdown sequence, which begins at T-minus 10 minutes. And when the countdown picks up at 10 minutes, that's when the ground launch sequencer computer takes automated control of the countdown. You can see here this view from the west looking to the east, sunrise out over the Atlantic Ocean here on Florida Space Coast this morning. And we'll stand by for further news from NASA and the Artemis control team on exactly what these next steps might be to try to restore this bleed flow to engine number 3, which appears to be a constraint for launch this morning if it's not resolved. Latest update from us launch control is that one of those issues that we were discussing that involved the potential crack in the intertank area of the core stage, that concern has now been cleared. Engineers have determined that some frost and ice has built up in a crack in the foam, but there's the conclusion is that that crack is not an issue on the structure of the core stage itself. And NASA's launch commentator says that this is a phenomenon known as cryopumping that was observed back in the days of the space shuttle program with the foam on the external tank used on the space shuttle. And this similar issue has been observed this morning on the Artemis 1 core stage. So that concern has been resolved, no longer an issue for the countdown, which continues to hold now at T-minus 40 minutes. This is an unplanned hold to allow the liquid hydrogen team over in the Launch Control Center to come up with additional troubleshooting plans to try to recover this hydrogen bleed flow into engine number 3 that is providing insufficient cooling for that engine. That engine has not been able to reach its proper initial temperature. It needs to reach a certain temperature threshold before engine start. That's enabled by this bleed flow. The other 3 engines were able to reach that threshold, but engine number 3 has not reached that threshold despite several valve cycles, including pressurization tests of the core stage to try to drive pressure through that bleed line into engine number 3. That did not work. And now the team is assessing next steps and further options that they may be able to implement to try again to try to recover that bleed flow and get engine 3 back to its proper temperature for engine start. Here's a live shot from a camera view on top of the vehicle assembly building looking down toward the launch and landing facility. This is Air Force 2 carrying Vice President Kamala Harris arriving for today's launch opportunity, today's launch attempt for the Space Launch System and the Artemis 1 mission. Vice President Harris is expected to tour the Kennedy Space Center, visit facilities where the hardware for the Artemis 2 and Artemis 3 flight elements are being prepared for flight. The crew modules for the Artemis 2 and Artemis 3 Orion spacecraft are currently here at the Kennedy Space Center. So Vice President Harris will take a look at those, and she's expected to give a speech around noon Eastern Time. And she's arriving for an opportunity to view the Artemis 1 launch this morning. If the launch does go ahead, the countdown is currently in a hold at T-minus 40 minutes as the launch team works an issue involving the bleed flow into engine number 3 at the bottom of the core stage. This bleed is not providing enough cooling to engine number 3 to get it down to the proper temperature for ignition. So we're standing by for an update from the launch team as they discuss what their next steps are this morning. The countdown has been in this unplanned hold at T-minus 40 minutes now for more than 35 minutes. At the time of the hold, when this hold was begun, the NASA launch commentator said the hold was expected to last around 10 minutes to give the team time to develop a troubleshooting plan to present that to the launch director, Charlie Blackwell Thompson, and then get her sign off on that plan. But the hold has run longer than anticipated. The launch window this morning actually opens in 28 minutes. That's the opening of the 2-hour window for the Artemis 1 launch opportunity today. Runs until 10:33 a.m. Eastern Time. as the Space Launch System countdown remains in this hold at T-minus 40 minutes. There are some rain showers approaching the Kennedy Space Center and the Cape Canaveral Space Force Station area from the south. Those showers are moving north, and if they don't dissipate, they're expected to move over the Kennedy Space Center area and the launch pad in a short time. We're still waiting on an update from the Artemis 1 launch team on what their next steps might be this morning, as the countdown has been held up by this issue with the engine bleed flow into engine number 3. Engine number 3 is one of the 4 RS-25 engines that power the core stage of the Space Launch System. These engines are manufactured by Aerojet Rocketdyne. They're actually leftover engines from the Space Shuttle program. They consume liquid hydrogen and liquid oxygen propellants and produce more than 400,000 pounds of thrust each at sea level. And part of the countdown procedure leading up to liftoff to ready these engines for ignition is to actually chill down these engines, get them down to very cold operating temperatures before the flow of cryogenics into the engines at engine start. And this bleed flow involves flowing a little bit of liquid hydrogen into the engine compartment through some of the plumbing in the engines to condition these power plants for engine startup sequence. And we've heard from NASA that engines 1, 2, and 4 had a good bleed flow and reached their proper thermal conditions for ignition, but those conditions were not reached with engine number 3. And the launch team tried several troubleshooting actions to try to regain that flow into engine 3. Those involved valve cycling attempts, as well as pressurization of the tanks, the liquid hydrogen tank on the core stage, to try to force some of that hydrogen through the bleed line into engine 3. And then the most recent troubleshooting attempt that we've heard about was the closure of valves, the bleed valves on engines 1, 2, and 4, to try to force all of that bleed system pressure into engine 3. None of those troubleshooting attempts worked, and engine 3 still has not reached its operating thermal condition, the proper operating thermal conditions for engine start. This hold has now been running for about 45 minutes. For just joining us, I'm Stephen Clark, editor of spaceflightnow.com. We're reporting live on the status of the countdown of the Artemis 1 mission here at the Kennedy Space Center in Florida. The countdown is in an unplanned hold at this point as the team troubleshoots an issue with one of the engines on the core stage of the Space Launch System. While we wait for a word on the next steps, we invite you to please like our stream if you haven't done that already. You can also join our YouTube channel. We have various membership tiers available for you to choose from. Depending on which level you choose, you can gain access to exclusive video features from our work here at Cape Canaveral covering launch operations. We cover all launches here from Florida Space Coast. Of course, this Artemis 1 mission is one of the biggest in recent memory. You can also contribute and help support our coverage through the Super Chat function here on our YouTube channel. And if you haven't already, please subscribe to our channel so you can get notice of our broadcasts before we go live before each launch. You can also go to our Spaceflight Now store. Go to shop.spaceflightnow.com. We have a number of patches and other items of memorabilia there for purchase. Notably, related to this mission, on the left, we have the Artemis program patch available for sale, as well as the Artemis 1 mission patch. And then at lower left, we have a special commemorative Artemis patch available. These are all available in the Spaceflight Now store at shop.spaceflightnow.com. We mentioned a few minutes ago that there was a band of thunderstorms and rain showers approaching the Kennedy Space Center area, and this may not be an issue given that NASA is working this problem with the engine bleed valve, but the cumulus cloud rule has just toggled red, so the cumulus cloud rule is now red here at the Kennedy Space Center. The latest update from NASA's Artemis Launch Control Center is that the launch director Charlie Blackwell Thompson continues to discuss options with the cryogenics team on a path forward this morning. Still no word on how the team intends to proceed with this countdown. The Artemis 1 countdown continues holding at T-minus 40 minutes. NASA has provided another update on the status of this morning's countdown operation. NASA says teams are in a hold in the countdown at T-minus 40 minutes, while engineers continue to assess and issue conditioning engine 3, one of the 4 RS-25 engines on the bottom of the Space Launch System rocket's core stage. NASA says engineers are looking at options to gather as much data as possible, and that could suggest that the team is trying to gather information that could help them develop a plan to ultimately resolve and repair this issue after today's launch attempt. The launch window opens in 3.5 minutes and closes in 2 hours. And just based on the nominal timeline, just looking at the clock, not considering the time it may take to condition the engine number 3 on the core stage if the bleed was restored at this moment. Just looking at the countdown clock, there's about 80 minutes from right now until the earliest possible launch opportunity. But there are other factors at work, including the time needed to troubleshoot and restore this bleed flow, if it's at all possible, if it's even possible today, and then get the engine down to the proper conditions, proper thermal conditions. So with this engine bleed issue still unresolved, the odds of a launch this morning appear to be declining here at the Kennedy Space Center, but still no official word on a scrub from the launch team or the launch director at this time. The countdown has been in this unplanned hold at T-minus 4 minutes for about 1 hour and 4 minutes or so, maybe 1 hour and 5 minutes at this time. At the time of the beginning of the hold, NASA's launch commentator said the team expected the hold to last just about 10 minutes, so we're well beyond that. And again, the weather conditions are expected to become less favorable over the next few minutes, with a rain shower about to move over the Kennedy Space Center. And it looks like it's on a path to also move over the Launch Pad 39B area. But the weather is a secondary factor right now. The main concern is the engine bleed on engine number 3 of the core stage. And we've now hit the opening of this morning's Artemis 1 launch window. It's 8:33 a.m. Eastern Time. It's now 12:33 UTC. So this was the opening of this morning's 2-hour launch window here at the Kennedy Space Center for Artemis 1. But liftoff is not happening at the opening of the window, and odds of it happening before the end of the window aren't looking particularly favorable at this time.
NASA Launch Director Charlie Blackwell Thompson has just announced and confirmed a scrub. So the Artemis 1 mission will not be launching this morning. The next available launch opportunity, assuming this engine bleed issue that caused the scrub can be resolved, would be no earlier than Friday. NASA's launch commentator has now signed off, and we're not expecting to hear any more real-time updates from the Launch Control Center, but if you're just joining us, the launch was scrubbed by Launch Director Charlie Blackwell Thompson a couple of minutes ago due to this issue with the engine bleed on engine number 3 of the core stage of the Space Launch System moon rocket. Engineers have spent the last couple of hours evaluating this issue, and despite multiple different types of troubleshooting attempts, they were not able to get this flow going enough to cool down and thermally condition engine number 3, and it has to be at a certain temperature threshold. Engines 1, 2, and 4 met that threshold, but engine number 3 did not reach that thermal threshold. So the next step will be to back out of the launch countdown and drain the Artemis 1 rocket of its cryogenic propellants. The team had the rocket nearly fully loaded, not quite 100% full on all of its tanks. The core stage was fully loaded. The upper stage did not quite reach the full point, not quite the 100% levels on the upper stage. So those propellants will be drained over the coming hours. That's a multi-hour process to drain those propellants, just as it was a multi-hour process to load them. The next launch opportunity would be no earlier than Friday at 12:48 p.m. Eastern Time. That is the opening of a 2-hour window, so 12:48 p.m. to 2:48 p.m. Eastern, 16:48 to 18:48 UTC. But that launch opportunity Friday hinges on the successful resolution of this engine bleed issue, which is a constraint to launch. You're looking now at the engine bay on the core stage, the 4 RS-25 engines visible there. If we have our bearings right from where this camera is located, we believe engine number 3
is the engine in the foreground. The most visible engine on the lower left of this view is engine number 3. This wider view of the Artemis 1 vehicle, this looks from a camera on one of the lightning protection towers, looking toward the southeast, out over the Atlantic Ocean. You can see that rain shower that we discussed a few minutes ago is approaching the Kennedy Space Center area. It's currently already raining over Cape Canaveral Space Force Station next door. To the right, on the right edge of the screen, you can see SpaceX's Launch Complex 39A. So just to recap what happened with this countdown, the loading of cryogenic propellants began nearly an hour late due to a thunderstorms that brought the threat of lightning inside the 5-mile ring around the launch pad. That's a constraint for propellant loading. That lightning cleared, allowing the cryogenic tanking operation to get underway. There was a signature of a hydrogen leak in the tail service mast umbilical that connects the mobile launch platform with the bottom of the core stage. That leak was detected when the core stage liquid hydrogen loading transitioned from slow fill to fast fill. And after some troubleshooting steps, including the restart of, first of all, the termination of flow of liquid hydrogen, then the restart of flow into the core stage at slow fill mode, and then back into fast fill, it appeared like that leak level decreased back to within acceptable limits, and that allowed the core stage to be fully loaded with liquid hydrogen and liquid oxygen. So NASA got a full load of propellants on the core stage during this countdown, a little later than expected, behind schedule, but a full load of propellants on the core stage. And then the next step was to begin this bleed into the engine section to begin chilling those engines down for ignition. This bleed system also caused trouble back on a wet dress rehearsal, practice countdown on June the 20th. The launch team detected a leak in a 4-inch quick disconnect connector that flows hydrogen into that engine bay, into that engine compartment for chill down. NASA's launch team continued the practice countdown despite that leak. They masked that leak. It was not a constraint to continuing that countdown rehearsal. It would have been for a launch, but they were able to continue down to T-minus 30 seconds, gathering a lot of data and practice run through the countdown for the launch team. And then at that point, NASA rolled the Artemis 1 rocket back into the vehicle assembly building for final closeouts and outfitting for launch, and a repair to that hydrogen leak in the bleed system and that quick disconnect fitting, and then return the rocket to the pad earlier this month for today's launch opportunity for the Artemis 1 test flight to the moon. So that leak that was found back on June the 20th prevented the bleed flow from getting underway into the engines, and prevented NASA and the launch team from testing that bleed function. That was one of the items, one of the boxes left unchecked from that wet dress rehearsal. And it appears, at least right now, that may be related to the issue that caused the scrub today. We'll wait for further details from the NASA launch team. We hope to hear from them in a press briefing, potentially. We haven't heard official schedule for a press briefing yet from NASA to gather more details on exactly what happened. Now, a little more than 20 minutes since Launch Director Charlie Blackwell Thompson declared a scrub for today's Artemis 1 launch attempt. You're continuing to watch live views from Launch Complex 39B. This is a view from the top of the mobile launch tower looking down on the Space Launch System, which stands 322 feet or 98 meters in height. With this countdown, this launch attempt now scrubbed, the next step will be the safing and securing of the Space Launch System, as well as the draining of cryogenic propellants from the rocket. As you can see, that rain shower we saw approaching a few minutes ago has now arrived at pad 39B. Some rain is now falling out at the launch pad. And we'll still await further word later today or in the coming days on when NASA might be ready to make another run at launching this Artemis 1 mission to the moon. Hello again from NASA's Kennedy Space Center in Florida. You're looking at live at Launch Complex 39B at the Orion spacecraft, sitting on top of the Space Launch System moon rocket following today's scrub countdown. NASA Launch Director Charlie Blackwell Thompson declared a scrub at around 8:35 a.m. Eastern Time, about 35 minutes ago, due to this issue with the engine bleed flow leading into engine number 3 on the bottom of the core stage. This is one of the 4 RS-25 engines on the bottom of the core stage of the Space Launch System. And here's a view up close of that engine bay at the bottom of the core stage. You can see these 4 RS-25 engines. These are leftover engines from the Space Shuttle program. All have flown on the Space Shuttle before. And we believe, if we have our bearings right on where this camera is, engine number 3 is the one on the lower left in the foreground. You can see these engines are wrapped in thermal insulation, a heat shield, a heat barrier, where they connect into the core stage engine section. The bleed flow is designed to feed a little bit of liquid hydrogen into the engines to begin conditioning them. This is a procedure that's known in the rocket business as chill down. The engines have to be at a certain thermal threshold, temperature threshold, to be ready for ignition and ready for flight. 3 of the 4 engines reached that threshold with their bleed flows this morning, but engine number 3 did not. The launch team performed multiple troubleshooting steps, cycling valves, increasing pressure in the liquid hydrogen tank to try to force that fluid, that propellant, through the bleed line into the engine. None of those activities got the result that the launch team wanted, though, and ultimately the launch director declared a scrub. It's not officially known yet when the next launch opportunity might be for the Artemis 1 mission. Just based on orbital dynamics alone, the next opportunity to launch the mission would be no earlier than Friday. There's a 2-hour launch window available Friday, 12:48 p.m. to 2:48 p.m. Eastern Time, 16:48 to 18:48 UTC. But that will hinge, obviously, on the resolution of this engine bleed issue, which is a constraint to launch. NASA has launch opportunities beginning Friday, September 2nd, as well as September 3rd, 4th, 5th, and 6th to begin the Artemis 1 mission to the moon. If the launch isn't off by September the 6th, the next launch period opens on September the 19th. But there are other constraints and factors that the team will have to consider. One of those, obviously, is if the repair to this engine bleed requires access to certain parts of the vehicle or the ground support system, the tail service mast umbilical, for example, the rocket could have to be rolled back to the VAB, to the vehicle assembly building, for that repair work. And that repair notwithstanding, if the rocket is not off the ground by September the 6th, the NASA team will have to roll the vehicle back into the VAB anyway for servicing and testing of the flight termination system, which is only certified for 25 days after the testing of that system. And that clock will run out after the September the 6th launch opportunity. And NASA officials have said if the rocket has to be returned to the vehicle assembly building, it would be very difficult to have the rocket ready to fly in the next launch period, which runs from September the 19th through October the 4th. So if a rollback to the vehicle assembly building is required, that would almost certainly push the next Artemis 1 launch opportunity into October. But we'll wait and see what NASA says, what the engineers determine might be the cause of this engine bleed issue, and what could be done at the launch pad. The teams will be assessing their options before deciding on a path forward. Before we sign off our live countdown coverage, we'll ask you one more time, if you want to support our coverage, you can become a member of our YouTube channel. We have different membership tiers that you can join at depending on which level you join at. You can gain access to exclusive video features on our YouTube channel, and you'll also be helping us continue and expand our launch coverage. Also, if you haven't already, please subscribe to our YouTube channel. And you can also like our YouTube channel to help us gain a wider audience for our launch coverage as well. And if you're a collector or if you're interested in space flight memorabilia, you can go to our Space Flight Now store. That's shop.spaceflightnow.com. And there you can purchase mission patches. On the left, we have several related to this flight. We have the Artemis program patch on the top left. Below that, there's the Artemis 1 mission patch. And below that, we have an Artemis commemorative patch available for purchase in the Spaceflight Now store. That's at shop.spaceflightnow.com. So we'll have further updates on the status of the Artemis 1 launch on spaceflightnow.com, as well as on our social media channels. So follow us there. And we thank you for joining us for our overnight coverage of the Artemis 1 countdown. The mission did not get off the ground today. We'll stand by and await word from NASA on when the team may make another run at launching this historic test flight. Until next time, I'm Stephen Clark reporting live from the Kennedy Space Center in Florida. Thanks for joining us.